Dozens of spacecraft and hundreds of probes take off from Earth and head for our planet's twin sister, Venus. It's about the same size as the Earth and has around 80% of our planet's mass. The temperatures here are too high for humans, and it doesn't have the air we're used to breathing. But we went there because scientists recently found traces of phosphine gas, which suggests that life might be there. Phosphine comes from various microbes and bacteria, so humanity goes on this journey to discover this life. With our technology, a flight to Venus would take 3.5 to 6.5 months, but we finally made it. Spaceships are landing on the planet, and when the first humans come to the surface, they see heat-scorched deserts, lava lakes, and geysers of poisonous acid. And that's it. Scientists miscalculated the radio telescope data. Phosphine never existed on Venus. So we're going back to the rockets, and we're getting ready for a longer trip across our galaxy. The scientists believe that there's at least 36 civilizations in the Milky Way that are similar to ours. They could be living organisms completely different from us. They may have different bodies, different eyes. They may walk and talk in a very different way than we do. But an advanced civilization has several criteria: technological progress and the use of developed communication between individuals. So, these civilizations must explore space, build cities, and be able to communicate with each other as independent species. Let's look at our galaxy and find these civilized worlds. So, the Milky Way is a spiral of 100,000 light years from side to side. If a star is born at one end of it in a super powerful blast, the light from that event won't even reach the other end until 100,000 years later. There's about 100 billion stars, and near each of them, there may be worlds similar to our solar system. Let's try to find these habitable worlds using giant sieves. First, we look for stars that have a lot of iron. Such stars burn at the perfect temperature for the development of life. And the iron in the star system will help form the cores of planets that will be home to another civilization. We sift the Milky Way through our sieve. We see that there are too many stars that fit the description, so we need another filter. Now let's find stars that look like the Sun in this pile. The star must be about 100 times larger than the Earth and 333,000 times heavier. An important criterion is the age of the star. When a star gets old, it begins to expand and turns into a red giant. At this time, it can absorb the planets around it. The life of such a star can end with a huge blast that destroys everything around it. So the star we're looking for must be relatively young. Let's use our sieve again. There's fewer stars, but still that's a lot. Now let's focus on the planets. They should be in the habitable zone of the star. Not too close to a star because then the temperature would be too high for life to be born. And not too far away. Then the planet would just be an ice block with nothing living on it. The temperature of the planet must allow the water to remain liquid. Another filter is the age of the candidate planet. It takes time for an advanced civilization to develop. Based on the experience of Earth, scientists believe that it takes at least 4.5 billion years for any life form to evolve to the human level. So we're looking for planets similar to Earth or older. We use our sieve one last time, and voila! We have 36 worlds where an advanced civilization is possible. Scientists conducted this study and published it in April 2020, based on these very criteria. All that's left is to discover these civilizations and make the first contact. We can detect such a civilization by using radio waves that come from it. Suppose there's a planet A with primitive living organisms on it. Millions of years of evolution, and they'll become a civilization with advanced technology. Radio waves will be the way they communicate. Then the whole planet will emit radio waves like a star emits light. And here on Earth, we'll be able to pick up this signal with antennas pointed into space. But there's a problem with the distance between the planets. For example, planet A is 1,000 light years away from the Earth. When planet A starts emitting radio waves, these signals won't reach us until 10 centuries later. We learned to emit and receive radio waves in 1895. And if the civilization on planet A emitted a radio signal at the same time, we won't be able to pick up that signal until 2895. It'll be the same on planet A. We sent a message in the form of a radio signal into space in 1974. In this signal, we encoded our number system, human DNA, and information about our solar system. If there's an advanced civilization on planet A, they'll be able to receive this signal only in 2974. And we'd have to wait another millennium to get a response from them. Another problem with radio waves is that they don't look like a constant glow on the planet but like a flare. Radio waves are only used at a certain stage of civilization. At first, it's the primary method of communication, but then we begin to use cell phones, cable TV, and fiber optics. And as technology advances further, our radio wave light begins to fade out. So we only have about 100 years of active radio use by civilization to find it. One day we caught a strange radio signal of an unknown origin. Its characteristics suggested that the signal was created artificially, perhaps by an outer space civilization or a passing starship. Further searches for this signal given no results, and this gave rise to many theories and arguments as to what it really was. It could have been a signal from Earth that reflected off a satellite flying through the sky, or it could have been the traces of a comet a few light years away. But let's assume it was a civilization from outer space, one of those 36 that probably exist. Now we need to make contact with them. So we throw our luggage into a rocket and head out in the direction of our suspected planet. Our rockets can fly at 17,600 miles per hour. That means a rocket could cross the entire United States in just 8 minutes. But even if an advanced civilization lived near our closest star, Proxima Centauri, it would take us about 73,000 years to get there. Even at the speed of light, it would take 4.2 years. So we need to solve the problem of space travel. Our scientists plan to reach about a quarter of the speed of light with a laser. A powerful laser beam from Earth will push a microscopic probe in the right direction. This probe could reach our destination in about 17 years. And in another 4 years, when the signal from it reaches Earth, we'll know if there's an advanced civilization. Another possibility for faster-than-light travel is the warp bubble spacecraft. The spacecraft would have to compress space in front of it and stretch it behind its tail. Then we'll be able to reach any point in the universe in literally a few seconds. But such travel remains a fantasy for us. Perhaps we can get to different corners of the universe through wormholes. They're shortcuts similar to tunnels, but there's one problem. These wormholes might be inside black holes. They're the most mysterious objects in the universe. They're so heavy that even light can't escape their trap. Our spaceships wouldn't stand the tension either. There's also a theory that Earth is unique because it was born under completely accidental circumstances. 4.5 billion years ago, our planet was a block of lava that began to cool and solidify. But its tranquility was broken by an asteroid the size of an entire planet flying by. The collision occurred at such an angle that the Earth was not completely destroyed, but part of the asteroid remained in our orbit. A heavy rock near our planet stabilized Earth's rotation, and the gravitational interaction with the giant debris caused our core to heat up. In addition, the asteroid brought a lot of water to Earth. Such a collision is extremely unlikely. It's like winning the lottery, many times in a row. But so far, we have no reason to believe life in outer space exists. Just as we have no reason to believe that there's no advanced civilizations in the universe, except for ours.
Ah, Earth. The third rock from the Sun. The blue planet. You get it. Its atmosphere is made up of around 78% nitrogen, 21% oxygen, and 1% argon, water vapor, and carbon dioxide. A nice balance for any living creatures to breathe. The weather here is also perfect for life to exist, unlike places like Saturn, Mercury, or any other celestial object in our solar system. We have the troposphere to thank for that. It's the densest part of the atmosphere on our planet and is 5 to 9 miles wide. It's the layer of the atmosphere that always affects our weather and secures the right conditions for life to exist and to have bodies of water. Earth is just sitting in its orbital path, minding its own business, revolving around the Sun until, BAM! Venus and Mars swoop in and spoil the fun. No one wants to leave poor Earth alone. These two relatively large celestial objects moving toward Earth will have dire consequences for our planet, starting with changes in its orbiting trajectory path. The planet's orbits in the solar system have to maintain the right balance so that nothing goes haywire. Of course, if any large object approaches Earth, it would throw our orbiting path off course. The planets will revolve around each other, which will cause plenty of natural disasters on our lands. This will also affect our rotation timing, potentially slowing it down. Days will not flow but drag by. Animals that rely on daytime will need to readjust their biological clocks. Nocturnal animals will also need to figure out how to cope with the long nights. Humans have adjusted pretty well to the 24 hours a day timing. Time itself is just a human construct to measure things. We'll have a tough time sleeping and adjusting to the stretched day. Marine animals rely on the natural current flow to migrate around the oceans. With Mars and Venus crashing the party, it looks like they will also need to find new paths. Birds migrating to other lands throughout the year will also be confused and not know what to do. In general, the Earth's temperature will rise, and massive heat waves and permanent climate changes will occur. This brings us to our next issue, the heat. The radical temperature rise will turn everything into a barren desert. It'll be summer all year long, especially if Venus is in the picture. Most of the planet will dry up and won't be suitable for growing crops. Venus is hot, really hot. Even though it's not the closest planet to the Sun, it's still the hottest. The temperatures on Venus are close to 900 degrees Fahrenheit, which will melt you like an ice cube. The lands on Venus are generally flat, probably due to the temperatures. It's mainly hot because its atmosphere is thick and traps the hazardous gases inside. If Venus inches its way towards us, it'll invite those gases to our atmosphere and compromise it. Mars, or the red planet as we know it, is very cold. That might stay the same if it starts rotating around us. It's also home to the largest dormant volcano in our solar system, which makes Mount Everest look like a tiny bush compared to a tree. With so much instability, it might just wake up one day and spew out molten lava. Mars has a very thin atmosphere, which makes the planet chilly. Its gravity is quite similar to ours. It's actually very cold and has ice caps in the poles covered with carbon dioxide. The same's true for Mercury. You can only last there as long as you can hold your breath and be in the sweet spot between the sunrise and sunset. The three planets orbiting each other will eventually collide. It's just a matter of time. And the Moon, just hanging out like a fly on the wall, will be so insignificant that something will eventually throw it off course and another planet will capture it to its orbit. Or, in the most dire case, it will collide with one of the two intruding planets. Earth will experience extreme tidal waves like nothing before. The two new planets revolving around Earth will cause a major imbalance, making our gravity shift out of control. Each tidal wave will be bigger than the previous one and will cover the dry land. Plenty of little scattered islands in the oceans will be completely submerged. Coastal cities and towns will also be home to fish. Flat countries in general will need boats to get around. Dams and dikes won't be enough to stop the water from coming in. Everyone needs to move towards higher ground to escape the floods. With the climate getting hotter, the polar caps will melt like ice cream on a sweltering summer day and add to the water level rising. Within a few months, the whole Arctic will be nothing but liquid. But wait, there's more! The crust will wear out due to the instability of the Earth's surface and fluctuating gravity. The Earth's crust is mainly made up of oxygen, which means we're basically walking on air. We might experience more earthquakes than before, and dormant volcanoes will wake up from their deep slumber. The skies will be covered in ash, making flights impossible. No one can travel by sea or by air. Importing and exporting will become history. The overall climate will get hotter, just like in Venus. The three planets orbiting each other and their huge mass might even unintentionally welcome other planets and celestial bodies to join the party. So, what if Jupiter decided to turn up? Now, Jupiter is the largest planet in our solar system. To give you an idea, the Earth would be just the size of a grape if Jupiter were the size of a basketball. It also has the largest storm we can perceive. That's known as the red spot, a place twice the size of Earth that has hurricane-like storms that have been going on for hundreds of years. Now, by the time you're done watching this video, you can expect the storm to still be going at it. Since the planet is huge, gravity must be quite strong here. It also has many moons, some of them of our little Earth. There will be no room for any proper space among the planets. Jupiter's moons will be thrown off course and latch onto other planets around. Some of the moons might collide with each other, causing massive debris to be displaced all over the place. The gravity of the planetary party will attract comets to enter the atmosphere, potentially crashing down on us. Oxygen levels will deplete, so the Earth's crust crumbling will continue. It'll rip open the ozone layer, causing heavy strokes of ultraviolet waves to enter our atmosphere. We won't be able to step outside for too long without some protective gear and oxygen tanks. Human civilization will change drastically. We'll all live in sheltered containers that will provide clean air and safe and filtered sun rays. The shelters will be sturdy enough to withstand frequent earthquakes. We will grow only enough crops to sustain ourselves until we leave the Earth. Since it'll only be a matter of time before the planets collide, the next step would be to create large rocket ships to fly us out of the Earth. With Mars, Venus, and Jupiter revolving close to us, it won't be easy to do so. All the space debris will be blocking us from exiting the space zone area. The only safe place outside this region will be many millions of miles away, where only single planets exist. They may or may not have the conditions to host life, but humans will have the technology to land just about anywhere with similar gravity and construct the right shelters. Eventually, Mars, Venus, Earth, and Jupiter will collide with each other and break like eggs, like a big space omelet. Don't forget the moon's crashing and breaking in the mix, but we'll already be far, far away by then, hopefully.
You and your camera have been literally everywhere on Earth, on top of Mount Everest and at the bottom of the Mariana Trench. You've seen the Nile River, Niagara Falls, the Sahara Desert, the Grand Canyon, and a million other beautiful places. On every trip, you brought back breathtaking pictures. Your album is already as thick as an encyclopedia, and it's time to discover a whole new world of tourism. Let's head on a voyage to Mars. You're sitting in a shiny modern rocket, counting down for takeoff. It might seem like a big deal, but with modern technology, it's practically a ride on a bus. In only a couple of hours, you're on the surface. It's time to head to the first destination for any tourist on Mars, Olympus Mons. It's the size of the entire state of Arizona and is 16 miles high. That's 3 times the size of Mount Everest. And it's the highest mountain in our entire solar system. It's actually even more than a mountain. It's a giant volcano. This entire mountain was formed when streams of lava rose to the surface, flowed down the volcano's slopes, and slowly cooled. The freshest soil layers are about 2 million years old. So scientists don't rule out the possibility that this volcano will wake up one day. Hopefully, you're not close by when it erupts. And there are statues of Greek deities everywhere. There's Apollo, and there are Athena and Artemis, and here's Zeus and Neptune. In the myths, these deities lived on Mount Olympus in Greece. These aren't natural, of course. We built these monuments to attract more tourists. There are even plenty of souvenir stalls where you can buy a lightning t-shirt in honor of Zeus. You take your first picture on Mars and move on to the next exciting place. This is a complex of 12 giant volcanoes. Some of them reach almost the height of Olympus. It's like if you piled 60 Empire State Buildings on top of each other. They're so tall because gravity is much weaker on Mars than on Earth. There isn't as much force pushing down on them, so they can grow much bigger than anything you could find on Earth. You feel lighter than you've ever felt before, and you can lift objects 3 times as heavy as you could back home. It's easy to see why the volcanoes are so big when you jump and fly 9 feet into the air. These volcanoes have been erupting for almost 2 billion years. That's almost half the age of our home planet. That's another reason they've gotten so tall. Click! The photo is ready, and you get on the rover to explore the next landmark, Valles Marineris. This is the largest canyon in the world. It's longer than the distance from New York to Miami, and it's 4 times bigger than the Grand Canyon here on Earth. We don't know exactly how it came to be, but the most popular theory suggests that it was all because of the lava, which pushed the crust upward as it moved underground. Over time, these valleys grew into the enormous canyon of Valles Marineris. The next stop is Cydonia. The cool thing about this place is the giant rock with a human face. In 1976, we saw photos from the surface of Mars and could clearly recognize a human head here. People immediately came up with 1,000 theories as to how it could have appeared here. The fun theorizing and speculation came to an end, though, when new photos were taken in 2011. These clearer pictures showed that the eyes, nose, and mouth were just shadows that couldn't be picked out in the original low-quality image. In fact, it's just a hill, a lot less exciting up close. Wear a warm jacket to view the next landmark spot. This is the North Pole. Make sure you keep a tight hold of your camera, too. It's pretty windy out here. That ice that you see is carbon dioxide, which looks like that because of the extremely low temperatures. It can get cold here at negative 226 degrees Fahrenheit. This cold place and the North Pole are responsible for the strong winds all over the planet. And there are even geysers at the South Pole. In spring, when it gets warmer, jets of carbon dioxide rush to the surface, taking dust and sand with them. Quick, get it on your camera. Various studies say that there is an underground lake as wide as Delaware Bay, 1 mile beneath a thick layer of ice. Moving on to Gale Crater. This is where the Curiosity rover landed in 2012. Oh, and here's its replica. This little guy has been studying the surface of Mars for years and has found signs of evaporated water. This means that Mars could have fostered life in the past. The rover also found a lot of evidence of organic molecules, as well as methane gas. It could come from microbes and other living things, but we don't know enough yet to say for sure. The existence of life on Mars hasn't been confirmed, but it's exciting to think that there could have been real Martians alive at some point. You take a selfie, like you're holding Curiosity on your arm. Great, the Mars cab is already here for you, and you're heading toward Medusae Fossae. Many people believe that this could be an alien crash site because of the strange appearance of these rocks. Of course, that's not true. Scientists suggest that volcanoes have been erupting here for years. Lava has cooled into rocks, and strong winds have given them strange shapes. This entire volcanic deposit covers an area the size of a fifth of the United States. And here's a place that has made Earth scientists nervous and even scared. Hale Crater and these lines on the slopes. Studies have shown that this place was moistening, meaning that water could flow there. But then it was determined that it was dry sand streams. Scientists fear this place may be home to alien microbes, so you probably shouldn't get too close. Another mysterious place for tourists on Mars is ghost dunes. In the ancient times of this planet, there were dunes dozens of feet high. But then, they were flooded by water or lava. Their bases are preserved, but the tops have been erased. The covered areas of these dunes can still harbor microbes. Here, they are protected from wind and solar radiation and may still be preserved. Contact with them can be dangerous for humans, so you take a photo from afar. The next spot is on Mars's satellite, Phobos. Oh, there's a pretty big crowd of people gathered here. And then you see it, Phobos monolith. It's a massive rock as tall as a 30-story building. We learned about this object from pictures taken back on Earth. The monolith casts a great shadow and has spawned many theories. For example, some claim that it was built by an ancient civilization or was left here by aliens. It might even have been a beacon. All these people came here to test the theory for themselves, but it just looks like a rock up close. One more photo, and you have to hurry to the bus that will take you to Jupiter's satellite, Io. It's only safe to be here in special capsule cars that fly over the surface. And when you see volcanoes constantly erupting, you understand why. Jupiter's gravity compresses the insides of Io. They heat up and rise to the surface, erupting in volcanoes on its surface. They eject so much material that Io completely changes its surface every few millennia. Now we turn on the hyperdrives and head out into deep space. Here, in complete darkness, is the Voyager probe. It was launched in 1977 and is still in operation. It's the first human-made object to leave our solar system's borders and is the world's most distant spacecraft. Voyager carries a golden disk with a message for extraterrestrial civilizations. This amazing disk contains pictures of Earth's landscapes, people, animals, and various sounds and music. Unfortunately, it will take many thousands of years to reach the nearest star system, so we're not very likely to hear back from any aliens anytime soon. You take selfies and move on to the next part of the tour. Here, 1,000 light years from Earth, is a black hole, the most mysterious and heaviest object in the universe. It weighs as much as the sun, but it's much smaller. It's so heavy that it attracts absolutely everything, even light. So the black hole isn't actually black. It has no color at all. You can only observe it from a very great distance because it bends time. The closer you are to it, the slower time will go. And if you want to fly just a second closer to it, weeks or even months might pass on Earth in that time. In the old tradition, you toss a coin into the black hole and continue your journey through the distant cosmos. On the way home, you have to stop by an iconic spot on the moon. Here in the Sea of Tranquility, there's an entire park near the landing site of Apollo 11. This is where the first human set foot on the surface of the moon. Neil Armstrong's first boot print is still there on the surface as proof. It was made in 1969, but even now, it looks exactly the same.